and welcome to everybody. It's really a pleasure to talk to you. And today what I thought I'd do is your students have presumably taken the AP Environmental Science exam, and you're finishing up your semester or your year, and I thought we could talk a little bit about incorporating current events into your AP Environmental Science course, either at the end of the year when you're looking for some more fun things to do, or what happens when some kind of an environmental science catastrophe or event happens next year, and how do you best respond to that? So that's what I'm going to talk about today. And as Cindy mentioned, if you want to use the chat and type in any questions to her, she'll be monitoring that during my about 45-minute presentation, and she may interrupt me with a question or two that's relevant, or we may save them to the end. So at any rate, please try to make this as interactive as we can for one of these webinars. And I picked two that have happened, one not a long time ago, but a few years ago. April 30th, right before the AP exam a few years ago, the Deepwater Horizon oil spill occurred, and it really wasn't clear how big it was and how many gallons or liters of oil was coming out, and it really took a number of months to get a good number. And so some of the issues that you're working with is you're working minute to minute, day by day, and how do you get good information? Perhaps some of you did deal with, just very recently, the fertilizer plant accident, or maybe now it's not an accident, but it was certainly an explosion, and people were making gaseous ammonia there, and there was a fire. So those are the kinds of things that we'll talk about. And so I want to first describe my background and my teaching philosophy and my involvement with AP Environmental Science. And I want to introduce, I know some of you are using our book and some of you don't know it, so I want to introduce our environmental science textbook very briefly and just tell you about some of its features. And then mostly what I want to do is present sound methods for researching and using current events to engage students and teach important AP environmental science topics. So that is the kind of the agenda for the next 45 minutes. My background is that I was an undergraduate environmental studies and biology double major at the University of Pennsylvania, and I did graduate work in what was then called the Department of Geology, but today it's been renamed the Department of Earth and Environmental Science. In 1995, I was asked to chair the committee that created AP Environmental Science, and for 3 or 4 years I worked with a committee of high school teachers and college teachers, and we developed the first few exam offerings. The success of AP Environmental Science, I think you all know, the first year that there was an official exam offered was 1998, and 5,000 students took the exam. Last year, it was about 115,000 students took the exam, and I don't know the numbers for this year, but I bet we'll learn them in a few weeks. So that was my main involvement was 1995 to 1998, but then in 2008 and 2009, I was asked to be a member of the CDAC, the Curriculum Development and Assessment Committee for the College Board, which was kind of a reevaluation of AP Environmental Science roughly 10 years later. And so I've been, as recently as 4 or 5 years ago, involved in other aspects of AP Environmental Science. But I've also been working on a textbook since around 2000 with some great people and with my co-author, Professor Rick Relier at University of Pittsburgh. Rick has an undergraduate environmental forest biology background, and then he did graduate work in ecology and evolution. Rick teaches at the University of Pittsburgh. He has frequent contact with high school science teachers in his lab and offers summer workshops in field ecology for high school teachers. I still do a fair number of AP environmental science teacher training workshops, so I'm involved in a variety of ways. So both of us are involved with people teaching environmental science at the high school level as well as doing our college and teaching and research as well. For me, it's been a privilege to have been a part of the team that developed AP Environmental Science and to have contact with so many APES teachers. And it's just really just wonderful to see that the course has really taken off and continues to grow in numbers of students taking it each year. And now that we have a book out, our contact with teachers is weekly and sometimes daily as more and more teachers adopt our textbook and write to us with comments, feedback, corrections, errors that they find. So I want to say thank you to all of you, including some of the people on this webinar today who've been working with me. And I see now that Libby Jones has some headphones and she has audio, and I mentioned earlier that Libby has been helping me with running a Facebook page that I'll post the name of it later on so you can find it if you want to. So for the purposes of our course, and I know some of you are logging in because you're getting ready to teach AP Environmental Science for the first time this fall, but I'm guessing most of you are just finishing up teaching it for your first or maybe your 10th year or somewhere in between. In the context of the AP Environmental Science curriculum, environmental science is the study of the natural world and interactions with humans. There's a few social science things like economics and legislation and governance of certain environmental acts that fall in there. But for the most part, we're talking about environmental sciences and natural and physical sciences. When I teach Intro to Environmental Science at Dartmouth every fall term to about 85 or 90 students, and I've been doing that for about 25 years. And I like to provide breadth and depth. I like to provide breadth to show the overall aspects of environmental science, and then I try to go into depth in a few subjects during the term. So it's not just a survey, but we go into some depth in a few issues. I like to use quantitative reasoning when it's needed. I like to show people that you can do a calculation and figure out, well, which has a greater energy impact, driving your car a certain distance or sitting at home with the air conditioner on. You can do those kind of calculations, and those are things that are needed in environmental science. And they're also quite useful in the AP Environmental Science course. I try to be as neutral or unpoliticized as possible. I know that's not always possible to be completely neutral, but I try very hard. And whenever I can, I use relevant examples, and that's what we'll be talking about today. I think these things are well represented in our book, and our book, in my opinion, conveys a modern synthetic approach to environmental science. We integrate global change and sustainability throughout the book. In fact, each of our chapters ends with a working towards sustainability, a story about something related to the chapter content that is today where somewhere in the world somebody or a country or a group is promoting and working towards and perhaps achieving sustainability in that realm. We use quantitative reasoning, as I mentioned before, and this ability is essential to success on the AP Environmental Science exam. So we use that in each chapter. We have boxes and do the math boxes and so on. We use examples. It is the only book that was built from the start for AP Environmental Science, and we have a number of features, including the do the math boxes that I talked about, checkpoints, AP-style multiple choice questions, AP-style free response questions, and another feature that I'll show you later on called measuring your impact, which is a nice little feature for understanding what it is that you're doing with respect to a certain issue. So here's a brief contents of our book, and one of the things I want to point out to you is that each of our sections is the same as the Acorn book, Environmental Science Course Description Topic. So the living world is one of the sections in the Acorn book, and biological and human populations is another, and so on. So we've organized our book in the same general sections as you see in the Acorn guide, and not only that, but the edges of our book are color-coded so that if the Earth System chapters are blue in the table of contents, you can actually look at the edge of the book and you can find where they are because they're colored blue. The physical pages of the hard copy book are color-coded to correspond to these. So just some of the features that are in our book. But the main focus of today's talk, we'll see some other examples from the textbook later on, is hard as it is to believe, some students are only moderately interested in environmental science. It's not their passion, and they might just be taking the course. for a variety of reasons. I thought it might be fun for this webinar to try to look at some breaking news events and how you could use those to attract the attention of students that maybe aren't as engaged as others. And I'm sure this happens to you all the time, and some of you have done this, so I hope you'll type into the chat and bring up some points or bring up some other things that I'm not mentioning. But I thought this would be a fun way to try a webinar after your students have taken the AP Environmental Science exam, and maybe some of you are still looking for what you're going to do for the next few weeks or however long you have school still in session and students are meeting. So maybe one or two of these ideas that I'm presenting today might be of value to you. So what I want to do is identify some responsible, accurate websites for good information, because whenever something happens, you are probably, like me, scrambling to find good, accurate information about that event. And two examples that I thought we'd look at are the recent fertilizer plant explosion in West Texas that I mentioned, and another one that seems to come up all the time, literally weekly or certainly monthly over the last few years, is the whole issue of meat consumption and what kind of meat, whether or not you're a locavore or not, and the whole issue of food miles and carbon expenditure. So some of the important things to do are, and what we'll do later on is just to have another little discussion about distinguishing among speculation and information, or distinguishing between speculation and information. And the newest item that I don't think we'll get to, but you may have seen in the news that the Malalona Observatory, 400 ppm, that the atmospheric concentration of carbon dioxide is 400 ppm as of a few days ago. So those are some of the things. I don't see any hands being raised. I don't see any things from Cindy so far, so I'm going to go ahead and, does that sound good, Cindy?
Yep, we are good to go.
Okay, so the first one that happened on April 17th of this year, and some of you were probably teaching that next day, there was a fire, an explosion and fire at a fertilizer plant in West Texas. And it was an absolute tragedy. Between 5 and 15, I think ultimately, this is a headline the next day, and I think ultimately the number might be 14 people were killed. And it, as this particular headline showed, it highlights the dangers of anhydrous ammonia production. It also helped to highlight for those of us who are teaching environmental science the fact that all kinds of energy choices and all kinds of agricultural choices that we make have consequences. And it also might have helped you doing some summaries or rehashing, because I imagine you presented this earlier in the year, understanding the nitrogen cycle. So now, more recently, it was deemed just a few weeks ago in the Atlantic as a fertilizer plant explosion, and then last Friday, it's now being investigated as a criminal probe. Was there, in fact, some kind of sabotage or terrorism involved in this? So it sort of highlights the pitfalls of when you're standing on your feet with news that's only a day old or a few hours old, all kinds of things can be going on. So even right now, we don't know what the story is with the Texas fertilizer plant, but we can use the fact that this was in the news and it was brought to people's attention and maybe everybody was talking about it, that you can look at the basic nitrogen cycle. So here's figure 312, the first half of it from our chapter 3 in our textbook. And if you look, it talks about here as how does atmospheric nitrogen, N2, become fixed, become available to plants as ammonia. Right here it says how does this happen? It says some fertilizer production is part of the process. So you can make use of this, or maybe some of you did, that this is part of the way that nitrogen becomes available to plants. So the two major pathways that plants assimilate nitrogen is by taking ammonium up into plants or nitrate. And so the fertilization process is taking fertilizers. Of course, if this is an organic fertilizer, it might be plant material that's decomposed and composted and applied to a field. But if it's a chemical fertilizer, an industrial fertilizer, it's using energy, usually in the form of natural gas, to fix nitrogen, that is, to convert atmospheric N2 to ammonia gas. So there was an opportunity that I imagine some of you took and brought up that point. Here's the second half of that figure that shows that the overall process, nitrogen fixation, converts N2 from the atmosphere. And so we don't make a distinction in that generic term, nitrogen fixation. Is it biological fixation by plants, or is it industrial fixation by human beings using something like generally natural gas, methane, to fix nitrogen? So that's the basic process, and what is one of the consequences of having all that nitrogen become available is that some of it runs off after fertilization. And so you might end up with waterways and drainage ditches and rivers and streams that end up with an abundance of nitrogen, in part because we've made so much of it available with this nitrogen fixation. So some of the things that might be clues, these are two figures on the left that are not in our textbook, but you might see those depending on the community that you're in. Anhydrous ammonia in a tank, and here it is actually being applied or being towed behind a tractor and applied as a gas into the soil and applied to the field. One of the things that we have in our book is showing the energy subsidy of agricultural activities. So this is the calories of energy input per calorie of food produced. And we're showing that there are some highly energy intensive activities like feedlot beef and far offshore fishing that might be up as much as 20 calories of energy subsidy for each calorie of, say, swordfish or tuna that you obtain. But the other thing is it shows that many different kinds of terrestrial agriculture, the fields with corn, for example, are using they're using fossil fuel inputs of a variety of forms, and that includes chemical fertilizer inputs. So the reason why something like large-scale corn at 0.5 calories of energy input for every calorie of food grown is so much greater than small-scale corn is in part because of the fossil fuel inputs that are going into the fertilizers, possibly the pesticides, possibly some other things. But those are the kinds of things that you can bring up and you can connect to a story in the news like a fertilizer plant explosion. We have some text in our book. This is on page 290, and we don't use the name the Haber-Bosch process, and I don't know how many of you use that name when you discuss it, but we're talking about the process of manufacturing synthetic fertilizers uses fossil fuel energy. So in particular, producing nitrogen fertilizer is an especially energy-intensive process. So you're using natural gas to take N2 from the atmosphere and convert it to ammonia. And plants do this, or certain plants, legumes, are doing this in association, their roots in association with a bacteria, and so it's nice to make that contrast of using a natural process using a fossil fuel-driven human process. And it's not necessarily that one is better than the other, but they're different. And the chemical, human-synthesized fertilizers are generally more available more readily and more immediately, and that sometimes can lead to more runoff into the streams. So those kinds of things are going on, and they're worth talking about, and these are all things that you can sort of bring up and emphasize if the news headlines work to your advantage. Another point is to say that this is what our energy profile looks like in the United States, and we are using slightly more than a third of our energy in the form of oil, and that comes into play in food production, but probably in the transportation aspect of food production. And actually also in the fields, tractors are often run, so applying fertilizer could very likely be done with oil. The chemically synthesized fertilizers are probably being done with natural gas, and then anything involved with electricity in the food production process is maybe 45–50% of our electricity comes from coal. So depending on where you live, all of these fuels are involved in the food cycle. And for that matter, so could nuclear and renewable energies as well. But maybe something on the order of 1/5 of the energy in this country is used for food production and transportation and preparation and refrigeration and cooking and all the way to consumption. So you could expand from a headline such as we just saw about a fertilizer plant explosion and work your way through a large number of things related to food and the results of what happens when you add fertilizers to fields. So that might be one thing you could do. And so just to give you some take-home messages to think about, or you've probably already thought of these, is that the specifics of fertilizer manufacturing is not a component of AP environmental science. That is, it would be highly unlikely for a question on an exam to go into great detail about how is it that nitrogen fertilizer is made. But there are a lot of things that AP environmental science students should know. Fossil fuel energy is used to produce commercial fertilizers, and as we discussed, depending on how much you go into detail, not too many of the textbooks go into a great deal of detail, but taking N2, atmospheric N2, and converting it to ammonia, NH3, and then possibly ammonium, NH4+, and then possibly to nitrate, NO3-. But you certainly could expect your students to know that fossil fuel energy is used to produce commercial fertilizers, and that added fertilizers interact with the natural elemental cycle, such as the nitrogen cycle that is occurring in the absence of human interference. So these are some of the, maybe big take-home messages that you could use a current event like a fertilizer plant explosion to emphasize that are very much related to the course curriculum, the understanding of material in AP environmental science, and could possibly be, exam testable material. So what do I use, or what did I use for some of that information? Unfortunately, I don't have a website that I say is the go-to place all the time. I tend to use the major newspapers, so I tend to use the New York Times and the LA Times and the Washington Post. Sometimes National Geographic has some good images and information that I go to. Nature, the peer-reviewed journal Nature, arguably Science and Nature are the two leading journals, and depending on if your school has access to that journal, you can get some good news there. I like a free website that Yale School of Forestry and Environmental Studies publishes called E360, Yale Environment 360. And you can't go there for breaking news, but usually within a week of an event, they come up with some really good articles. And so the Facebook page that we have and that we maintain, I sometimes link to Yale Environment 360 articles, so I like those. The Wall Street Journal, I find online Wall Street Journal sometimes has some very good scientifically accurate articles. We might want to get into a discussion this later on, but I find the op-ed page of the Wall Street Journal is not necessarily scientifically balanced, and perhaps you'd like to discuss that with me in about 20 minutes or so, or half an hour. But certainly the news articles, to me, at least seem fairly reasonable. And here's one in particular from National Geographic about the explosion related to the fertilizer plant in West Texas. So those are some things that you might want to look at if you get a chance. And as Cindy said, this PowerPoint file will be made available to anybody who wants to. Just let Cindy know that you'd like a copy of it. It's about 6 or 7 megabytes, and you'll get the raw PowerPoint file. So you can take those slides and import them into your talks, or use them, or modify them, or do whatever you want. So that's what we'll do there. So that's sort of like one segment that I thought I would do, is a recent explosion that was in the news. But the other one, as I mentioned at the beginning, is this issue issue that keeps coming up, I find, with high school students and college students, and it has to do with eating locally. It has to do with carbon miles and sort of like your carbon footprint from your diet. And it even comes into things like, would you have your meat consumption to save the environment? And this was an article that appeared in the New York Times just 3 months ago. But I think a number of you know what I'm talking about. These show up all the time. So I want to go over a few things that I think you could bring up with this. And I don't know, I guess it depends on your students and their interests, but I find this is something that people want to talk about a lot. What is it that you eat, and could your choice of diet have an impact on the environment? And it's a difficult subject, and so it's a good subject for after the AP exam if you get special projects going. I think this is a good one to assign students to because it's definitely a challenge. And what I want to point out is a series of articles and different things that have come up. One of them is here's from Forbes, Forbes.com, and this is an opinion. This is the locavore myth written by James McWilliams, who has written a book on food and food miles and food history, and he has more or less an opinion piece, why buying from nearby farmers won't save the planet. So this is James McWilliams. He's a professor at a university in Texas. I can't remember right now which. And I like this graphic. I'm not sure I highly recommend the article that it came from. I thought there were some things in there that didn't look that good to me. So sorry, this is probably not fair to these people to X out over that. But I did want to sort the graphic, which was cool. It had a carrot flying in an airplane. It has a train showing food transportation. It has some tomatoes that are on a truck. Why should I care? I thought it looked like a nice, here's a gasoline can. So it looked like a nice graphic. And if you're wanting to get into this some more, if you search food miles and carbon, you'll find a lot of different things. So I imagine you are very familiar or somewhat familiar with this subject, but the basic idea is, as James McWilliams writes here, buy local. Shrink the distance food travels, save the planet. The locavore movement has captured a lot of fans. To their credit, they are highlighting the problems with industrialized food, but a lot of them are making a big mistake. By focusing on transportation, they overlook the other energy-hogging factors in food production. And here McWilliams uses an example that has been cited over and over again, a 2006 academic study that discovered that it made more environmental sense from an energy perspective for a person in London, England, to buy lamb that was shipped from New Zealand rather than to buy lamb raised in the United Kingdom. And even though this is counterintuitive, the New Zealand lamb is raised on pastures with a very small carbon footprint, whereas most of the English lamb is produced in intensive factory-like conditions with a large amount of fossil fuel input. So in this particular case, the amount of energy used to transport the food is relatively small relative to the amount of energy used to grow it. And we have that example right here where I live. There's a local organic tomato greenhouse, a huge greenhouse that uses a lot of fossil fuel energy, liquefied petroleum gas, LPG, very close to natural gas, to grow tomatoes in the middle of the winter. And the energy footprint from these organic, very healthy to eat tomatoes is much, much higher than tomatoes that are grown in California or Florida and trucked all the way across the country up to Vermont and New Hampshire, where I live and work. It's just hard to believe, but the energy input from the local tomatoes is greater. It's the same idea. So I want to present this to you, and if you have students that are interested and you're looking for a project to do, if you just do a search in any search engine, food miles and carbon, I think you'll be off to a great start. So here's one study that people cite still quite a bit. It's a 2008 study by Chris Weber and Scott Matthews, both from Carnegie Mellon University in Pittsburgh, and it's food miles and the relative climate impact of food choices in the United States. And I've taken a little bit of the abstract of this article, and here's a link to the article, and it's still a widely and heavily downloaded article. And basically what the authors found is that, as you can see right here, transportation as a whole represents only 11% of the life cycle greenhouse gas emissions that come from consuming some food. So they looked at the entire life cycle supply, from some planting the seeds and fertilizing the fields and irrigating the fields and growing the crops and the processing and the transportation all the way to the cooking. And they found that transportation is a relatively small part, and that it's the energy put into growing the food and harvesting the food and even cooking the food, or certainly processing the food, is much greater. And so one of the conclusions that Weber and Matthews write is that we suggest that a dietary shift can be a more effective means of lowering an average household's food-related climate footprint than buying local. And I don't want to make it, and the authors make it clear that they don't want to make it one or the other. It's not like, oh, okay, so I'll switch from eating beef to eating chicken, and I don't need to buy anything local. In fact, there are many important aspects to buying local food, but I just want to show you the first and maybe the most important finding. This is the relative intensity, so it's normalized to beef, because red meat is the blue bar, and it's showing you like carbon dioxide equivalent released per household, HH stands for household, carbon dioxide released per dollar spent, carbon dioxide released per kilocalorie of food content, and carbon dioxide released per kilogram of food by weight. And they find that in every case, red meat, which is the blue bar, is the most energy-intensive food item. And if you look at things like chicken and fish and eggs, so one could say, you know, if you wanted to switch from eating beef to eating chicken and eggs and fish, that it would look like that. So what they're saying in one of their conclusions of their paper is that if you went from just one day a week not eating meat, maybe let's assume that you eat red meat every day of the week. If you went from one day and you went from here to here for that day, you're at least for that meal, you know, or at least for that main course of your food, you would reduce your carbon dioxide emissions by more than 50% to go from here down to here. So that's the kind of point they're making. It's counterintuitive, and it might be a very provocative and interesting thing for you and your students to look into. So the authors of the paper admit that these are not the only calculations to make. Some people like to talk about eating seasonally. That is, you eat what's available in your area at the time. And also to eat less processed food might be a good thing for health reasons, and also because with less processing there might be less energy input. So the senior author, who is, you know, in the midst of this still controversial and heated discussion about what is the way to lower your carbon footprint and how important are food miles, I learned from World Watch Institute. They published a paper saying that Weber followed a vegan diet for 10 years, and he calls himself somewhat of a proclaimed foodie. He says that one thing that's really great about local food, and the reasons that I buy local, is because you can actually know your farmer and know what they're doing. So this is not an argument against buying local. That is, you should buy local for many environmental science reasons, including knowing and being able to observe how your food is prepared. But it might be that you should eat seasonally. That is, you should eat local foods when they're locally in season, and perhaps look at an overall analysis that doesn't only include the transportation energy input, but looks at how a food is grown, what are the energy inputs, and of course there are many things to consider other than energy that you might want to get into, such as what kind of a product contributes to what kind of erosion, what kind of land fragmentation, habitat fragmentation, all kinds of other implications of choosing one food versus another. But this is the kind of thing that you might want to look at in a discussion about food and energy, because as we know and as we point out in our Chapter 12 textbook chapter on energy, all energy use has consequences. And this is not a fertilizer plant, but this is a gasoline refinery, but it's quite a complex manufacturing process to refine fossil fuels or to refine oil into its different products. And there are explosions, and people certainly die in these kinds of plants as well. In our chapter opener, so each of our chapters opens and has various things to say. In our Chapter 12 fossil fuel chapter, we talk about oil spills, we talk about coal mine explosions and the respiratory ailments that affect coal miners. We talk about strip mining and mountaintop removal. We talk about natural gas, which is clean burning, but it does have exploration and extraction impacts, and it still is a fossil fuel. So even though it's releasing 50% of the carbon dioxide as oil for the same amount of energy content, it's still releasing fossil carbon dioxide. But the big issue, and another one of these in the news today kind of issues, is fracking. So depending on where you live, hydraulic fracturing for natural gas is a major news issue that's coming up all over, well, certainly the eastern United States, but other places as well. And so you can go from here and more traditional fossil fuels like oil, petroleum products, you can go here. And the bottom line is the U.S. is dependent on fossil fuels for the bulk of our energy use and the bulk of our food production, transport, and processing. So there are numerous environmental impacts of using energy. Refinery explosions is one. Fertilizer plants is another danger. Exploring food miles and how you get your food and where you get your food from all work their way into these discussions. So those are things that I think you could definitely be talking about. There are other things that I just want to recognize that they're going to happen in the future. This is in 2011, the earthquake and tsunami that then led to 3 of 6 nuclear reactors in Fukushima, and the power plant in Fukushima, Japan, were without electricity. And what slowly over a course of a series of days became a bigger and bigger environmental crisis. And obviously something like that would allow you to make use of describing the nuclear power plant and how this containment core is different than in a conventional, say, coal-burning power plant. But once you generate steam, the steam turns a turbine, which turns a generator, which goes out to the grid. And so that part of a nuclear power plant is the same as a conventional fossil fuel or thermal power plant. Here's what I did, because from the time the AP environmental science textbook came out and we wrote a college textbook called Essentials of Environmental Science, I had to boil down with some relatively new information, because I think I was doing this in April or May of 2011. The book came out in January of 2012, our college book, and I had to boil it down to some information. And so like you're kind of making decisions, and I was able to say that an accident that is considered equal in severity to Chernobyl occurred in Japan on March 11th, 2011, and I think that still is true. And I said that because of the physical damage and interruption of the electricity supply to the plant, 3 of 6 nuclear reactors operating experienced fires, hydrogen gas explosions, and the release of radioactive gases. Assessment of the effects on people and the environment are still underway. The 3 reactors were almost certainly damaged beyond repair. I was being careful there. I think now there might be some people that are saying that actually 4 of the reactors are damaged beyond repair and are never going to be operating again. So these are the kinds of things that I had to do before my book went out into print, the one that Rick Relier and I were modifying from the AP Environmental Science textbook to make a college book. But really, you're doing the same thing when you're in your classroom and you're presenting information, and I'm doing the same thing when I present the information in my classroom. So those are the kinds of things that you have to do. Another one that was a real challenge, I bet some of you were teaching during the Deepwater Horizon spill. It was right before the AP exam 3 years ago, and no one knew how much oil had leaked, and no one knew exactly when it was going to get capped and so on. So these are challenges that we face, and I'm not saying that there's any immediate or guaranteed way to get good information, but I think using the major news sources, major news services, and finding the same information from different news sources might be an indication that you're looking at good information. It might also be that everybody's getting the same erroneous information from one source, but I'm sure you're familiar with that as well. Here's a graph that if you are talking about different forms of energy, I've not really found a better representation of this. Perhaps if some of you have, show me or send it to me or type it in the chat and let me know. But this is showing the greenhouse gas emissions by fuel type. So it's using grams of carbon equivalent, so that is carbon emission equivalent, and it normalized it to kilowatt hour of energy. But it could have been joule, it could have been BTU, it could have been calorie, it didn't really matter. But what it showed is that coal is the most energy intensive. That coal, particularly coal-fired electricity, is the most energy-intensive way of, the most carbon-intensive way of generating electricity or using energy. That is, you're going to release the greatest amount of carbon. And then you can see oil is less than that and natural gas is less than that. And you can see the natural gas is roughly half of the emissions of coal. And that's why it's so advantageous, if you can, to convert coal generation of electricity to natural gas generation of electricity, because you get the same work done with only 50% of the carbon emissions. And so when people are, maybe with good reason, skeptical or challenging or disparaging of hydraulic fracturing for natural gas, you do have to acknowledge that that is one important consideration, that if you can leave the coal in the ground, and I'm not sure you can, but if you can leave the coal in the ground and you can use natural gas, one immediate implication would be there'd be half as much carbon dioxide emitted for the same amount of work done. And you can see that solar photovoltaics, hydro, biomass, wind, nuclear are all much, much lower. And there's probably more range of the nuclear than this diagram, because some people weigh the carbon emissions from building the nuclear power plant, which are quite energy intensive to build a nuclear power plant, might be a little bit more than that number indicates. But at any rate, I like this graph. I've not seen a newer and cleaner representation of it, but I just thought I'd put it in here in case you like it too and want to use it. I think you can talk a lot about making photovoltaic panels and the energy intensity. It's like making an iPhone or an iPod or any kind of laptop. There's a lot of semiconductors in clean lab kind of conditions that need to be used to make photovoltaic panels, and so that's where some of those carbon emissions come from, and so on. So I do want to point out in the last few slides that we have in our textbook issues related to food and related to these topics that might be showing up in the news. Here's a do the math box in Chapter 11 on page 288 that says, what are the energy requirements to raising beef relative to other things? And so if you were going to raise corn, how many calories could you get out of it? And if you are going to use that same land and raise beef, how many calories would you get out of it? So we walk you through the calculations, and then at the end of most of our do the math boxes, we give you something else. Your turn. How many people eating a beef-only diet could Earth support? And given the information you have here, a student could figure that out, and then we don't put the answers in the book in case you want to assign it, but we do have on our website in the instructor resources, we have the solutions for these things, and we show that if if 6.8 billion people require 2.72 billion hectares of land, if we were going to eat beef only, if we were going to get all of our calories from beef, and if there's only 1.5 billion hectares of land available, it means that we've got a ratio of that 1.5 to 2.72, which is saying roughly maybe 3.75, 3.8, a little more than half the people eating a beef-only diet would be supported on that amount of land. So that's one of our features, these do the math boxes, which are, there's one or two in just about every chapter. We also have in the back of each chapter in the book multiple choice questions that are in the exact same format as you see. So we didn't really have a question that I found easily in our book that was exactly relevant to what we were talking about today, but here's one. Farmers who practice organic agriculture have less of an impact on the environment than farmers who practice industrial agriculture because they use no-till agriculture exclusively, import soil to maintain soil fertility, maintain large farms with a single crop, avoid pesticide and synthetic fertilizers, have lower labor costs, and the only one that is absolutely true is D. By definition, organic agriculture avoids or isn't allowed to use pesticides and synthetic fertilizers. Certainly that's the best answer of the choices. We also have free response questions, so I mined our book and found on page 308 that we had a free response question asking about concentrated feedlot operations, and we were able to give some data and ask some questions and have students to do a series of calculations that might be similar to a free response question on an AP exam. And we also have something that's close to figuring out the carbon footprint of food consumption. Here's a feature that we have at the back of each chapter called Measuring Your Impact, where it takes one of the subjects from the chapter, gives the student more information, more data, and then asks them to do some calculations on what would the footprint be in terms of, in this case, hectares per year of land that might be needed. So that's the kind of thing that you might, be thinking about or using if you want to. So what we did here is we identified a few accurate websites for good information. We talked about the fertilizer plant explosion, meat consumption. It's important to say that you have to be vigilant as information comes out. It's not always the best. We have to distinguish between speculation and information. The newest news item is that atmospheric carbon dioxide concentrations just hit 400 ppm a few days ago. I mentioned that earlier on, and that might be something to do. So one person, Kim Forgy, wrote in and said, students really resist reading articles, and do you have sources for video clips? And there are good video clips, but I don't know that I know of a particular website to go to. Generally what I do is I use YouTube and I search for a particular subject, and then I kind of have to vet them myself. But one thing I have to say about YouTube is if you look at the comments that are liked the most or end up rising to the top as the most liked, very often those comments are decent. I don't know how it is, but the YouTube community gets right to the heart of the issue. And there might be profanity in there and there might be bluntness in there, but sometimes I'll just show my class when I show a YouTube video in class, I'll show, well, let's see what the first comment is. And I have no idea what's going to rise to the top of the list at the moment of my class. It might be different than it was a few hours earlier when I looked at it, and there might be some language in there that isn't appropriate to put in a class, but sometimes it's valuable. But sorry, Kim, if I'm not thinking of something right now, if somebody knows of a good site, maybe they could type it into all participants and give a suggestion. But I'm not coming up with a video, like a guaranteed high-quality video clip website. But if I think of anything, I'll get back to you, and that's a really good question. So,
actually, Andy, I'm going to interject, not for videos, Kim, but we did have a couple recommendations of other sites, websites that might be of interest to the other participants. The BBC site. Do you use that, Andy? BBC.
I guess occasionally, but not on a regular basis.
So this was one that Clive Tattersall had recommended, and actually the lead article is about Joe Farman, who was one of the people who identified the hole in the ozone layer over the Antarctica. Just passed, and interesting, lots of interesting articles. I don't see that there are any videos on here, but another potentially useful website. And then Clive had also shared about, where was it? The visualization of CO2, informationisbeautiful.net. Have you seen that, where it has different representations
No, I haven't.
of CO2, which was interesting. Actually, I can...
Okay, well, I don't know. I don't know if anybody is has any particular sites at their fingertips, but if you do, the Island President documentary about the president of the Maldive Islands. Yeah, I've seen that. That's a good video, but that's a long one, right? Kim Walsh wrote in and brought that one up, but that's like an hour and a half long, I believe. So I agree that I like using, sometimes in class, to break things up in the middle to illustrate a point I've just made. I might show a 2 or 3 minute video clip, but I don't have a specific way to get a hold of them, or I just search, and that is not always the best way to do it. So I hope we can...
Oh, sorry, Andy, there was another
suggestion.
Education-portal.com for video clips. Education-portal.com for video clips.
Okay, thanks for that one. That's good. I don't know that, so yeah, that's great. I hope we'll get a few more questions, but the last slide I wanted to show you was that both Rick Relier and myself are happy to get emails, and we welcome emails, and we welcome what worked for you, what didn't work, any corrections, any questions, anything you want to bring up. Please feel free to send us an email and let us know what we've been doing well and what we can do better. Also, we do have a Facebook page that I mentioned Libby Jones helps me moderate and contribute articles to. So you can look through the old posts to get some ideas if you want, and most of those are topical. Libby and I are seeing things that we read during the day, and as I mentioned earlier, I put a lot from Yale Environment 360, which I think are very readable articles, and they're not too long, and they're informative, and they're, for the most part, balanced. They're certainly accurate, but every once in a while I think there's a little bit of bias and a little bit of advocacy creeping in there, but that's okay, and particularly if you ask your students to look for it, it might be a really good educational tool. So that's what I have to say, or what I prepared to say, but I'd love to talk some more if some questions come into me or come into Cindy. It's 6:25, so in theory we can hang on here if you have the time for 5 more minutes. So I thank you for listening in and watching, and for typing in the comments that you've sent in so far. And as I said at the beginning, I've really appreciated the interactions I've had with people about our book and about the subject matter of environmental science, and I just welcome more comments and more feedback and input over the coming months and years. Thank you.
There was one comment back when you were talking about McWilliams and the lamb example, that just a tidbit of information. He's at Texas State University in San Antonio, and he's actually a history professor.
Thank you. Yeah, okay, so I didn't remember. I knew it was Texas, but thank you for that. And yes, he's a history professor, so it's interesting. And so you might not want to rely on him. I don't want to disparage historians, but you might not want to rely on him for, say, some of the most precise food numbers, although I think his numbers are pretty good. But that's why I also cited that paper, which has got its issues too, and its critics. So one thing that I think is really useful is to look at who has cited this Weber and Matthews paper that was in Environmental Science and Technology, which is a publication of the American Chemical Society in 2008. And if you can do forward citations, who has written about this paper in 2009 and 2010, and even recently the Freakonomics website and radio program picked up on this and wrote about it. So those are some things that I'd recommend, I'd encourage you to do if you're inclined to do so. But it's worth, it certainly will get your students thinking, and it may challenge your better students to really get a hold of this whole subject.
Okay, we have a couple questions coming in, Andy. This is my first year teaching AP. Do you believe the approach of reading the entire book is best, or supplementing, as you've discussed, going along with major topics?
Okay, that's a great question, and I think that's going to depend on your class. If the book itself is a lot to get through, I'm not sure how much you will want to supplement. So it might depend on your students and if they like to read additional things, or if you're assigning special projects and you want to assign some outside things. I certainly wouldn't be expecting it to happen every week, or maybe not even every 2 weeks, but perhaps once or twice during the year if you did do some depth. And I bring this up because, remember at the beginning I said I like to show the breadth of environmental science and give people an appreciation of all the different systems and all the different cycles that the AP environmental science curriculum requires. But it's good to go into depth in an issue or a couple of issues. And if you pick a robust issue such as energy or food, or maybe biology related to food webs and the trophic pyramid, there's some hope that not only will students gain knowledge and gain some just grounding in understanding how complicated and complex environmental science issues can be, but it may also be that a free response question on the exam relates to something where they get to show off the fact that they do know greater depth than just survey level on certain things. So I don't know if that helps you, but ask again or ask more if that doesn't. That's my biggest problem with these WebExes, is without the interaction immediate, real time, it's hard to know if I've answered the question you asked.
Another question was about a colleague at Dartmouth, David Blanchflower, on environment and economics. Have you had any discussions with him?
Danny Blanchflower. Yeah, okay. So I've talked to him a little bit. He has some strong opinions about a lot of environmental, economic topics in general. So no, I haven't seen him in quite a while, but he's around and he certainly publishes widely and writes in various op-ed columns and articles, and absolutely sees a strong economic role and cost for true costs of items for making economic and environmental decisions.
Okay. And then another question. I'm wondering how frequently you plan to update the trend type figures in your textbooks. As new data becomes available over time, can teachers download updated figures as they're available?
That's a great question. We've just been going through and updating some figures. We haven't figured out a way to make newer figures available, but we do, for example, have an errata page when we find corrections. I think we found about 5 or 6 truly, numbers that are wrong, or when we gave the number in hectares, we did it right, but when I made my conversion to acres, I messed up, or something like that. So, Cindy, is there a way we can does everybody who's using the book, they have access to that website, but sometimes people forget about it? Can you speak to that for a second?
For sure. So what Andy's talking about, we have a book companion site, the BCS, which is available to all adopters of the Friedland-Relier text. And we do provide updates in addition to the errata sheet that, like Andy said, there's only about 5 or 6 corrections there. But we do provide, there's new PowerPoints that were shared with adopters on that book companion site. There's videos where you have a math professor actually doing the calculations for, as Andy had talked about, one of the features in the printed book is the Do the Math calculations for students to practice, but there's actually videos on the book companion site as well of a math professor doing the calculations step by step for the students to view. There's some more questions coming in. There's actually another audio website recommendation. Bob Murphy suggests that to Kim's question, stateimpact.npr.org is a site that he uses for it's a radio show recording that he uses as a podcast to play in class. Answering an earlier.
That looks great, and I see it says a lot of Texas environmental issues, and Texas has a lot of environmental issues that are relevant to other states because, Texas isn't just oil and gas, as Bob, but wind. Wind is a big component of energy generation, electricity generation in Texas, so that looks like a good one. stateimpact.npr.org.
Very good. Well, we're just a little bit over, and I'd like to end on time, so I want to thank everybody for joining us this evening. As we said earlier, this session was recorded, and Andy has offered to share his PowerPoints if you're interested. You all have my email address from the invitation to the WebEx. I welcome you to communicate with me, and we thank you for your time and attention.
Thank you very much. Don't forget to write to either of us if you want.
Very good. Have a great night, everyone. Thank you.
Bye.
Bye-bye.